All right, so let's practice our newly learned skills, or hopefully, if you're watching this video, it's just a refresher of skills you already know. So looking at this diagram of the Grand Canyon, which starts with the Kaibab limestone all the way on the top, going all the way down to the metamorphics and the granite at the bottom, I want you to look at the two fossils that I have shown on this, one in that tan Sapai layer, the other one farther down in that dark brown bright angel layer. Which fossil is older? Right? Hopefully you knew that the principle of superposition tells you oldest rocks are on the bottom, right? So that means that that trilobite is the older fossil. Okay, next one. We've got one fossil in the Docks Formation, another fossil in the Shinimo. Oh, it's a good question. How do you pronounce that? I don't know. Which fossil is older? Okay. Again, this one's a little trickier because you can no longer just think, well, which fossil is above the other one, because these rocks are not perfectly horizontal. They have been tilted, so you have to remember the principle of original horizontality, meaning that these rocks were once flat. So the Shinimo Formation is beneath the Docks Formation, such that that spiral nautilus shell is the older fossil. All right, next one. Which fossil is older? We have one fossil in the Bright Angel Formation on the far side of the canyon, another fossil in the Bright Angel Formation on the closer side of the canyon. Which one's older? Well, hopefully I couldn't trick you. You know that because of the principle of lateral continuity, they're the same age, right? Even though they are on opposite sides of the canyon now, that rock layer, that Bright Angel Formation used to be all one continuous layer, all deposited at the same time, so those fossils would be the same age. All right, next one. Which fossil is older? We have one fossil in the Docks Formation. We have another fossil in that blue dike that is cutting through the Docks Formation. And you know that because of the cross-cutting relationships, the principle of cross-cutting relationship, whatever is doing the cutting, which is that blue dike where that trilobite is, has to be younger than the formation that's being cut, which is the Docks. So that spiral nautilus shell has to be older. It had to exist before the dike cut across it. Now you may be asking yourself, how can we be sure? Right? How do we know that these principles are correct? Well, we assume that these principles are correct because of the final principle, the biggest principle, the most important principle, the principle of uniformitarianism. And this one states that the past history of Earth can be explained by what we see happening today, right? We assume that the physical laws, the chemical laws that we observe today were also true in the past, right? Today, the sun makes heat. So I can assume 1 million years ago, the sun was hot. Right? Today, volcanoes produce magma. So I can assume 10 million years ago, volcanoes produced magma, right? Anything that we can observe today, we can assume was also true in the past. And because these principles make sense today, we assume that they had to have also made sense in the past.